Hello guys, welcome on Tesla Adventures. In this video today we are going to discuss the solutions of that JEE mains mock test which was having the syllabus of rectilinear motion and projectile motion. So let us start from section 1 which has 20 questions, and those 20 questions are each is of SCQ single correct choice. So now this question number 1 says that a ball is thrown vertically up in the air where the resistive force can be considered to be constant. If the time of ascent is t1 and time of descent is t2, then the ratio of velocity of projection to the velocity just before it hits the ground is we have to find out that. So we know that obviously in this case the ratio of time of ascent to time of descent, so t1 once again, so t1 by t2 is equal to under root of, you know that t is equal to under root of 2h by g. So when the ball is going up, then the air friction would be acting in the downward direction and mg would be acting in the downward direction. So let us suppose that the air resistance has an acceleration a, so t1 would be under root 2h by g plus a, and time of descent would be under root of 2h by g minus a. So this t1 by t2 will be equal to under root of g minus a upon g plus a. This is the first term. Now we know that if we have to find out the velocity ratio of the velocity of projection to the velocity it hits with the velocity with which it hits the ground. So we know that v is equal to under root 2gh. If h is the height which it has attained, then we can say that v projection v1 upon v2 will be equal to under root of, at the time of projection the air resistance and g was acting in the downward direction, so this ratio would be g plus a upon under root of g minus a, because at the time of descent the air resistance was acting in the upward direction and g was acting in the downward direction. So v1 by v2 would be equal to t2 by t1. So the correct answer is option A. Now we move on the next question. In this question you can see that there is an object which is thrown horizontally from point A from a tower, and it hits the ground 3 seconds later at point B. This line A to B makes an angle 30 degree with the horizontal. So we have to find out the initial velocity. So this is a simple one. So if this height is h and this range is r, so we can say that this angle is also 30. So tan 30 will be equal to h by r, and tan 30 is 1 by root 3. So h is equal to r by root 3. This is the ratio between, this is the relation between h and r. We also know that the time of descent of this stone would be under root of 2h by g, and the range would be equal to v into the horizontal v into the time of light. So range would be equal to v under root of 2h by g. Okay, now this is the relation between these two. Now we can see that the v, we have to find out the v. So the time of flight, now h is equal to, or r is equal to, you can see that root 3h. So you can substitute the value here, and r is root 3h, so root 3h is equal to v under root of 2h by g, and squaring both the sides, 3h square is equal to v square into 2h by g, and cancelling h with h, you can see that this h will be equal to 2v square by 3g. This is the height, and r is the range. So obviously we can say, now in this question you can see that there is an object which is thrown in the horizontal direction from this point A, and it hits the ground 3 seconds later at point B. This line AB makes an angle 30 degree with the horizontal, and we have to find out the initial velocity of the object. So you can see that obviously if this is the range, if this is r and this is h, so we can say that tan theta, tan 30, this angle would be also 30, so tan 30 will be h by r, and that is 1 by root 3. So h is equal to r by root 3. This is the first equation. Now the second thing, we can say that the time of flight will be under root 2h by g, due to the fact that uy is 0. So if the y velocity initially is 0, then we can say that this stone is being dropped in the y direction, and if a stone is dropped from some height h, then the time it takes to reach the ground is under root 2h by g, and this time is 3 seconds. So 2h by g is 9, and h from this is 45, and if h is 45, r is equal to 45 root 3, and we know that the range is equal to horizontal speed into time of flight. So 45 root 3 will be equal to horizontal speed tv into time of flight will be 3 seconds. So v will be equal to 15 root 3. So the correct answer is A. Now we move on the next question. In this question you can see that there is a particle that is moving rectilinearly on a straight line, so that its acceleration is 3t square plus 1. So A is equal to 3t square plus 1, and its initial velocity is 0. So we have to choose the correct option. So let us first of all write it as dv by dt. So this is dv by dt, and it is equal to 3t square plus 1. I am having a little bit of wound in my right hand, so I'm having a trouble to write down anything, and I'm having some trouble to hold the pen. So my writing would be more worst than ever. So please, I request you all to cooperate for that, and I apologize. So this is V. I'll try to write down slowly and with the better words. So dv is equal to 3t square plus 1 into dt, and the initial velocity was 0, and at any time it was t. So the time is from 0 to t. So v will be equal to, this is t cube plus t. Limit is from 0 to t. This is v. And at t is equal to 1 second, v is equal to 2 meters per second. So this A option is incorrect. The displacement of the particle in 1 second will be 2 meter. So v can be written as ds by dt, and ds by dt is equal to t cube plus t. So ds will be equal to t cube plus t into dt, and I am integrating it. So s is equal to t to the power 4 by 4 plus t square by 2, and at t is equal to 1 second, you can see that s is equal to 3 by 4. So this is also incorrect. So particle continues to move in the positive direction. This is correct, and it is correct due to the fact that the velocity and acceleration are parallel to each other at all the times. So there is no question of changing the direction. So it will it will continue to move in the positive direction always, and the particle will come back to the starting position after some time. This is also incorrect, so the only correct answer is C. Now let us move on the next question. In this question you can see that a trajectory of a projectile is given, y is equal to ax minus bx square, where a and b are constants and x and y respectively are the horizontal and vertical distances of the projectile from the point of projection. So maximum height attained. See, we can solve this problem by two methods. We can use the projectile analogy, or we can use directly the maxima minima. So I'll prefer maxima minima, but because it would be smaller, so let us solve it by maxima minima. So dy by dx will be equal to a minus 2bx, and that is equal to 0. So x is equal to a by 2b. So we have calculated the value of x for which y would be maximum. So see, if you are wondering that how I can say that y would be maximum for this x, it could be minimum also obviously, but this is a motion, projectile motion, and the object is going away from the ground, and therefore the height would be maximum only, because the minimum height would be 0 itself. First thing. Second thing is the fact that I have already taught in maxima minima that if there is only single value of x to check the y, so we can just say that y would be maximum, because in the question it is asked about the maximum height. So y would be maximum at this point only, obviously. So at this point y max will be equal to a into a by 2b minus b into a square by 4b square. So this is a square by 2b minus this is a square by 4b. So this is a square by 4b. This is y max. So the correct answer is A. Okay, now we move on the next problem. In this question you can see that there is a particle that is projected at an angle of alpha, and after t seconds it appears to have an angle of beta with the horizontal. The initial velocity will be, so obviously we can say that this would be the trajectory, and let's suppose initial velocity is u and the projection angle is alpha. After some time its projection angle is beta. So first of all we can say that the horizontal velocity will be same. So v cos beta will be equal to u cos alpha. So v will be equal to u cos alpha by cos beta. This is the first equation. Now we can use the time in y direction, and we can say that vy is equal to uy minus gt. So vy is v sine beta, that is equal to u sine alpha minus g into time t. So the value of v is u cos alpha by cos beta into sine beta is equal to u sine alpha minus gt, and we have to find out the value of u. So you can see that it is u will be equal to, in fact let us separate the terms, gt will be equal to, u is common, sine alpha minus cos alpha sine beta upon cos beta. So gt will be equal to u into sine alpha cos beta minus cos alpha sine beta is sine alpha minus beta divided by cos beta. So the correct answer is B. Now we move on the next question. In this question there is a particle that is projected with a speed va from a point making an angle of 60 degree with the horizontal. At same instant, second particle which is in the same horizontal plane is thrown vertically upward from a point directly below the maximum height of the parabolic path of A and with velocity Vb. If the two particles collide, then what should be the ratio of V upon Vb? So this is a quite simple question. You can see that there is a particle which is projected like that, Va, at an angle of 60 degree, and there is another particle which is projected from a point which is directly below the highest point. These two particles will collide obviously at this point. It is given in the question, and at this point they will reach in the same time, obviously. So to reach this point in the same time, their y velocity should be same because their y acceleration is same. So their y velocity is Va sine 60, and that should be equal to Vb. So if we have to find out Va by Vb, then Va by Vb will be 2 by root 3. So the correct answer will be B. Now we move on the next question. In this question you can see that there is a velocity time graph of the particle is shown like that. We have to find out the correct displacement time graph. This is quite simple question. We know that when velocity time graph is a straight line, then the displacement time graph is a parabola, and if this straight line is going up, then that parabola would be opening to up. And from 2 to 4, so obviously from 0 to 2, the ST graph would be a parabola opening in the upward direction. Okay, now from 2 to 4, velocity is constant, and displacement time graph would be a straight line because velocity is constant, and this velocity is positive constant, so displacement time graph would be a straight line going up. And from 4 to 6, this line, this VT graph is a straight line going in the downward direction, and therefore we can say that from 4 to this point, the displacement will increase, and from this point the displacement will start to decrease. So obviously there would be a parabola opening in the downward direction. So we can say that the correct answer would be C. Okay, because you can see that initially this is a parabola, slight curve, and this is a straight line, and then this at position 4 displacement increases after 4 for some time, and then it starts to decrease, and then beyond 6 it is again a parabola which is opening in the upward direction. This is a slight curve. So now let's move on the next question. In this question you can see that a bullet is fired with a speed of 50 meter per second at an angle of 45 degree to the horizontal. We have to find out the height of the bullet when its direction of motion makes an angle 30 degree with the horizontal. So this is the situation, that if bullet is fired with 50 meters per second, this is u, and this angle is 45 degree, and at the time when its angle with the horizontal is 30 degree, then let's suppose its velocity is v. So 50 cos 45 will be equal to v cos 30, and this is 25 root 2, and this is v into root 3 by 2. So v will be equal to 50 root 2 by root 3, and we have to find out this height. So we can use v square is equal to u square plus 2as. So vy will be v sine 30, uy will be u sine 45, and g is in the downward direction while displacement is in the upward direction. So this is minus 2 g into h. So this is v square, and v square is 2500 into 2 by 3. Sine 30 is 1 by 2 and its square is 1 by 4, and u is 50, so this is 2500 upon, this is 2 because sine 45 is 1 by root 2 and it is square, so minus 2gh. So you can see that this is 1250 upon 3, 1250 upon 3 is equal to 1250 minus 2gh. So 2gh will be equal to 2 by 3 of 1250, which means 2500 by 3, and g is 10, so h is equal to 2500 by 3 into 20. So this would be 125 by 3. So the correct answer is A. Now we move on the next question. In this question, you can see that there is a graph of position of a particle moving on the x-axis as a function of time, and this we have to choose the correct option. So you can see that in first question it is mentioned that particle comes to rest 5 times. So obviously you can see that this particle, this graph is having its zero slope 5 times, 1, 2, 3, 4, 5, and we know that the slope of displacement time graph represents the velocity. So the velocity of this particle would be 0 5 times. So A option is correct. The initial speed of the particle was 0. This is incorrect because initially the slope was not 0 like that. You can see the velocity remains positive for t is equal to 0 to t is equal to 6. This is also correct because in between this time the velocity is becoming negative 2. The average velocity of the total motion is negative. You can see that the average velocity formula is the final displacement minus initial displacement upon time taken, and the initial displacement is this and final is 20. So the change in displacement is positive, and therefore average velocity would be positive. So the only correct answer of this question would be option A. Now we move on the next question. In this question you can see that there is a projectile which is projected from origin in xy plane, and the y coordinate of this projectile at time t is given by y is equal to 4t minus t square, and the x coordinate of the particle is given by 3t. So we have to find out that what is the angle of projection with x-axis. This is also a very simple question. So you know that y, if we apply the equation of motion in y, so y is equal to uy into t minus half ay into t square. And if we compare it with this equation, then uy can be seen as 4, and x coordinate is ux into t. And if you compare this with this equation, then ux is 3. So the angle of projection with x-axis is tan theta, and tan theta would be uy by ux. So it is 4 by 3, so theta would be equal to 53 degree. So the correct answer is C, tan inverse 4 by 3. Now we move on the next question. In this question, you can see that there is a particle which is projected up the inclined plane in such that its component of velocity along the incline is 10 and time of flight is 2 seconds. So what maximum height above the inclined plane? The maximum height above the inclined plane is also given as 5. So the velocity of projection. So simple is the case in this question. So we know that it is projected with some velocity u, and this is uy and this is ux. Okay, and this angle is, let's suppose, alpha. So we know that time of flight is 2 seconds, and 2 is equal to 2uy by g cos alpha. And we know that height is 5, so 5 is equal to uy square by 2g cos alpha. Okay, if you can find out the value of g cos alpha, then g cos alpha is from this one, g cos alpha is uy, and 5 is equal to uy square upon 2 into uy. So uy will be equal to 10. This is the y component of the velocity, and the velocity along the incline is given as 10. So the net velocity will be 10 root 2. Now we move on the next question. In this question, you can see that a ball is projected with a velocity u at right angle to the slope, which is inclined at an angle of alpha with the horizontal, and the distance x along the inclined plane that the ball will travel before striking to the slope. We can easily see that this is the inclined plane and this angle is alpha, and a ball is projected with such a velocity u such that it is at 90 degree from the inclined plane. So the time of flight will be equal to 2u by g cos alpha, and the range, it is asked in the question, so range will be calculated by half ax into t square. T is the time of flight, so it would be capital T. So range will be equal to half. Ax will be g sine alpha. So this is g sine alpha, and t square will be 4u square upon g square cos square alpha. So range will be equal to 2u square sine alpha upon g cos square alpha. This is the range, and you can see that the correct option will be option C. Okay, now this is quite obvious if you are thinking that how I have assumed that it would go in the downward direction, because if I would assume like that, so the acceleration is in the downward direction. If I assume that I have projected this projectile from the bottom, then the acceleration is in the downward direction, and if I have projected like that, it would go in the downward direction only. It would not go up the incline. So this is quite obvious that this projectile is projected from up the upper point towards the lower point. Now next, in this question, you can see that these two balls are projected from point A and B in the vertical plane as shown in the figure, and AB is a straight vertical line. If in this question it is given that these balls collide in mid-air if V1 upon V2 is equal to, so obviously initially they are on y-axis, and at the time of their collision the distance traveled by them in x direction will be same in the same time. So we can say that the velocity of each ball in the x direction will be same. So Vx1 and Vx2 would be same. So V1 cos theta 1 would be equal to V2 cos theta 2. So V1 by V2 will be equal to cos theta 2 by cos theta 1. So D is correct option. Now we move on the next question. In this question, you can see that a ball is shot in a long hall having a roof at a height of 10 meter and the velocity of 25 meters per second at an angle of 37 degree with the floor. This ball lands on the floor at a distance of this. We have to find out this distance. The collision which we have to assume is elastic. So obviously you can see that in the elastic collision, if the ball strikes this roof with velocity Vy, then roof rebounds the ball with the same velocity Vy in the downward direction. So we have to find out the time. We can say that the time of ascent and time of descent would be same. So we have to first of all find out the time of ascent. So time of ascent is, let's suppose, t. So to find out the t, let us use the equation s is equal to ut uyt minus half g t square. So s is the displacement of the ball. So s is 10, uy is the initial y velocity, which is 25 sine 37. 25 sine 37 into t minus 5t square. So 25 sine 37 is 3 by 5. So 25 sine 37 is 15. So 10 is equal to 15t minus 5t square. So t square minus 3t and plus 2 is equal to 0. So you can see that t will be equal to plus 3 plus minus under root 9 minus 8 by 2. So t will be equal to this is 3 plus 1 upon 2. So this is 2 seconds, and t will be also equal to 3 minus 1 upon 2, which is 1 second. So this is obviously the situation that there would be two times when it would be at 10 meter, but we have to take the first smaller time because in the case you can see that it is going in the upward direction at the time of ascent. So at the time of ascent it would be at a height of 10 meter at 1 second. So this is the time of ascent, and time of descent would be also same. So time of descent will be also 1 second, and the total time is 2 seconds. So this distance x will be equal to the horizontal velocity, which would remain same, which is 25 cos 37 into the total time is 2 seconds. So x will is equal to 25 into cos 37 is 4 by 5 into 2. So this is 40. So the correct answer is A. Now we move on the next question. In this question you can see that there is a particle P which is projected with the velocity u1 at an angle of 30 degree with the horizontal, and another particle Q is thrown in the vertically upward direction with velocity u2 from this point Q, which is at the bottom of the highest point of the trajectory of A. The necessary condition so that these particles will collide. See, obviously we have done such question previously. So u1 sine 30, if the y component of both of them will be equal, then they will collide at the top point. So u1 will be equal to 2u2. So correct answer is B. Now we move on the next question. In this question you can see that a ball is thrown from a bottom of an inclined plane at an angle alpha from the horizontal up the inclined plane, and another ball is thrown from a point on the inclined plane with the same speed at some angle alpha from the inclined plane surface down the incline. If in these two cases maximum height attained with respect to the inclined surface is h1 and h2, then what will be the ratio of h1 and h2? See, obviously, uh, this is not alpha. It is given that two balls are projected with the speed alpha. So you can see that in the two cases uy will be same, and obviously this, if this is theta, then g cos theta is same for both of them, so height would be same for both of them. You can refer the formula of height on the inclined plane. Now we move on the next question. In this question you can see that there is a particle which is projected from the inclined plane at an angle of 37 degree from the incline, and in the upward direction the inclination of inclined plane is 53 degree. The speed of projection is 10, and we have to find out the maximum height attained by the projectile. So obviously this is h max, and h max is uy square by 2g cos alpha. Now uy will be 10 sine 37, and 10 sine 37 is 3 by 5, so this is 6, and cos alpha, cos 53 degree is equal to 3 by 5, so h max will be equal to uy square, which is 36, and 2 into g is 10, and cos alpha is 3 by 5. So you can see that this is 2, this is height is 3, so the correct answer is A. In this question you can see that this curve represents the velocity time graph of a particle, and its acceleration values along OA, AB and BC are. So obviously along OA the slope of this graph would represent the acceleration, and the slope is 1. Along AB it is 0, and along B to along 20 to 40 it is C point. This is C point, so it would be 10 upon 20 with a negative sign. So 1, 0 and minus half. So answer is A. In this question you can see that this is the equation of a projectile, and g is 10, so we have to find out the range of the projectile. So obviously the range of the projectile is the value of x for which y becomes 0 again. So we can say that y is equal to 12x minus 3 by 4x square, and at y is equal to 0 there are 2 points when y is 0. First is the point of projection, so y is 0 at 12 minus 3 by 4x, and x is common, so one point is x is equal to 0, which is the point of projection, and other point is 3x by 4 is equal to 12, so x is equal to 16. So this is the range of this projectile. Now we move on the next question. In this question you can see that the velocity time graph of the body is given. The maximum acceleration we have to find out. See, in this case the acceleration is 0, in this region the acceleration is 1, in this region the acceleration is 60 minus 20, which is 40, divided by 10, so this is 4, and in this region acceleration is 60 upon 30, which is 2, so maximum is 4. Now we move on the next question. This is the section 2 in which there are numerical type answers questions. So in this first question, find out the range of the projectile on the inclined plane which is projected perpendicular to the inclined plane with a velocity of 20 meters per second. So obviously this is a simple question. We can find out the value of time of flight first of all. So time of flight will be 2 into 20 by g cos 37. So time of flight will be 40 by 10, and cos 37 is 4 by 5. So it would be 5 seconds, and the range will be ut plus half at square along the incline, and u along the incline is 0, so range will be half g. Now g is g sine 37, g sine 37, and t square is 25. So range will be equal to 1 by 2, g is 10, sine 37 is 3 by 5, and this is 25. So this is 5 and this is 5, so this is 75. The value of range will be 75. Now we move on the next question. In this question you can see that that a body is dropped from top of a building and it covers 7 by 16 of the total height in the last second of its fall. So what is the time of fall? So let us suppose that it takes total n seconds to fall down, and in last nth second it covers 7 by 16 of the total height. So let's suppose that the total height is h. So h into 7 by 16 is equal to, now we know that the distance traveled in the nth second is given by u plus a by 2 into 2n minus 1. Now u in this case is 0, so this would be just s is equal to a by 2, which is g by 2 into 2n minus 1. So 7h by 16 will be 5 into 2n minus 1, and 2n minus 1 will be equal to 7h by 80, and this is the equation. Now we know that n is the total time of descent and the height is h, so n will be equal to under root of 2h by g. So we can substitute the value of n in this equation, or we can substitute the value of h, which is n square into 5. Okay, I have used the value of g as 10, so this is h. So h is this one, so 2n minus 1 is equal to 7 into n square by 16, and you can substitute, or you can check, or you can solve the values of n quadratic equation, and I am just substituting the value of n here, which is the correct answer. So 2 into 4 is 8 minus 1 is equal to 7 into 16 by 16. So this is satisfied, so the correct answer is B. I'm not saying that you have to satisfy the values. You can solve the quadratic and you can find out the value of n. Okay, I'm just saving the time of the video. So let's move on the next question now. In this question you can see that a body starts from origin and moves along the x-axis such that its velocity at any time is given by 4t cube minus 2t. And what is the acceleration of the particle when it is at a distance of 2 meters from origin? So first of all, let us see that v is equal to 4t cube minus 2t, and a is equal to 12t square minus 2. And if we write down v as ds by dt, then it is equal to 4t cube minus 2t, and s, initially obviously the velocity was 0 and it starts from origin, so initially s was also 0, so I'm integrating it directly, so it is t to the power 4 minus t square. Okay, so when s will be 2, so if this is 2, then t square and this is t square minus 1 is 2. So this is the value, and we have to find out the value of acceleration. See, if you can see that this could be if you can find out the value of t square from this, if t square uh, is equal to 2, then you can see that t square into t square minus 1 is 2. So t will be equal to root 2. So a will be equal to 12 into 2 minus 2, which is 22. So the correct answer is B. Now we move on the next question. In this question, the correct answer is 22 because it is an integer type of question. And in this question, the correct answer is 4. Okay. And this is 75. Now in this question, you can see that this is a VT graph of a body, and we have to find out that in what time it would return to the starting point. So obviously we can see that the displacement S1 of the particle in the positive direction is half base into height. Base is 25 and height is 20, so S1 is equal to 250, and from this position, when it would travel in the downward direction, then we can say at some time t, let's suppose this is t naught. In this t naught time, it would return to the initial position. So the acceleration is constant through 20 and further time, because this is a straight line that is going in the downward direction, and acceleration is negative. Obviously it is 20 by 5, so it is minus 4, and the velocity at this point is 20. Okay, and velocity at this point is 0. So we have to calculate the time in which the body will cover 250 meters starting from rest. So 250 is equal to half, acceleration is 4, because now it is moving in the backward direction, and acceleration is also in the backward direction, so I am taking it as positive. So 250 is equal to 1 by 2 into 4 into t naught square. So t naught is this time, so t naught square is equal to 125. So t naught is equal to 5 root 5, and this is the value of time. And you can also find out this value in the by another technique. You can see that if this is t naught and acceleration is minus 4, which is calculated by this triangle 20 by 5, which is 4, and line is going in the downward direction, so it is minus 4. So this angle tan theta is 4. So if this is y or minus y, we can say that tan theta will be equal to y upon t naught, and tan theta will again be equal to 4. So y is equal to 4 t naught, and we know that area should be equal to 250, which is 250 will be equal to half base into height t naught into y. So 250 is equal to half, y is 4 t naught, so this is t naught square into 4. So t naught, you can see, is again root of 125, which is 5 root 5. These are the two methods of finding out this, but the answer is not 5 root 5, because we have to find out the total time. So total time would be counted from t is equal to 0. So it would be 25 plus 5 root 5. So 25 plus 5 root 5. Okay, so root 5 is I think approximately 2 point something. It is 2.23, and 2.23 into 5 is approximately 11.18. So t will be approximately equal to 36.18. Okay, Now we move on the next question. In this question, you can see that there is a particle which is moving on a straight line. It traveled half of the distance with velocity v naught. So if this distance is s, then s by 2 has been traveled by v naught, and remaining is covered in such a way such that for half time it moved with velocity v1, and for second half it moved for velocity v2. Now we know that v average of this motion, v average 2, will be equal to v1 plus v2 by 2, and for this motion v average is v naught, and for the complete motion v average is 2 v average 1 into v average 2 upon v average 1 plus v average 2. So this is 2 into v average 1 is v naught, and v average 2 is v1 plus v2 by 2 divided by v naught plus v1 plus v2 by 2. So cancelling this 2 with 2, you can see that it would be 2 into v naught into v1 plus v2 divided by 2 v naught plus v1 plus v2. So a is equal to 2 and b is equal to 2. So a plus b will be equal to 4. So the correct answer is 4. Now we move on the next question. In this question, you can see that there is a particle which is projected from the horizontal xz plane in the vertical plane, where x-axis is horizontal and positive y-axis is vertically upwards. The graph of the y-coordinates of the particle versus time is shown. The range of the particle is root 3. We have to find out the speed of projected particle. You can see obviously that this particle is projected from xz plane in the vertical xy plane, and x-axis is horizontal, positive y-axis is vertically upwards. So we can say that vy is slope of this graph at t is equal to 0, or initial velocity we can say uy is tan 60. This is a graph, this is not the trajectory. You should remember and you should carefully observe the question. So tan 60 is root 3, uy is root 3, and the range of the particle is 3. So speed of the projection. So obviously we know that the time of flight will be 2uy by g. So it would be root 3 by 5, and the range will be r will be equal to time of flight into ux. So ux will be equal to r by t. So r is root 3 and t is root 3 by 5. So ux is equal to 5. Okay, and u will be equal to under root of ux square plus uy square. So u will be equal to under root of 3 plus 25. So it will be root of 28, which is 2 root 7. So x we have to find out. So x is equal to 8. Now we move on the next question. In this question, you can see that there is a ball which is hit by the batsman at an angle of 37 degree with the velocity of 15 meters per second, and a man is standing at this point and he is running with some constant velocity so that he catches the ball before it strikes the ground. Assume that the height of the man is negligible as compared to the maximum height of the projectile. So we have to find out that velocity of the man. So obviously the time of flight of this ball will be 2 into u into sine 37 by g. So t will be equal to 2 into 15 into sine 37 is 3 by 5 and g is 10. So this is 3 and this is 5. So time of flight is 9 by 5. And in this time he has to travel a distance of 9 meter. So his velocity is Vm, and that is 9 upon time of flight, which is 9 by 5. So Vm should be equal to 5. So the correct answer is 5. Now we move in the next question. In this question, you can see that a platform is being pulled with the constant acceleration a, and a particle is projected from the platform at an angle theta with the horizontal with respect to the platform as shown in the figure. The value of tan theta such that the particle again comes to the starting point on the platform, which means that obviously with respect to platform the range is 0. Okay, and obviously we can say that if range is 0, then 0 is equal to u into t minus half a t square in the x direction. Now in x direction, the relative acceleration of ball with respect to plank is minus a, which is minus 5. Okay, and ut will be equal to half at square and u will be equal to at by 2. Now a we have calculated is 5. We have already used this negative sign here. So a is 5, and time of flight can be what we have to find. We have to find out tan theta. Okay, so time of flight will be u. This is in the, we have applied this equation in x direction. So this is ux, this is ux, and time of flight is 2uy by g. Okay, so this is, so ux